Greetings and welcome, friends. Mr. Waddy here, and my algebra buddies. We've been talking about solving absolute value equations, which are a little bit tricky. In general, we've noticed that there are two solutions to these absolute value equations, and we've also figured out this little relationship between the equation and the graph of the solutions. I don't know if you guys remember, but we had x minus, and c was the distance, these distances away, right? Do you guys remember that? What was the b? B was, yeah, the middle, no thanks, of the graph. And what did these points represent? Yeah, those were the solutions. And usually there's multiple solutions, right? Those are the x values, x equals whatever those numbers are, right? Dot, dot, dot. There we are. So if I want to match these graphs without solving, but we'll go back and we'll solve one of them just to see, this is the way I would do it. So for 27, if x plus 2 is equal to 4, that means b is equal to -2. Yeah, that done be sneaky. And c is equal to 4. So the equation that matches this will have a midpoint at -2, distances of 4. It looks like b is the answer to 27. You got it. Opposite day. So check this out. If I wanted to match that here with my little McDonald's graph, x plus 2, the midpoint is at -2, and the distances are 4, so 4 units away. Actually, look, I've even got the slider over here, 4 units away. You can see I've got the same graph here, like so. Question, comment? Yeah, I'm sure you get a notification. Question, comment? C is the distance the solutions are from the middle. But let's solve this algebraically just to verify. How would I solve that algebraically? Yes. Yeah, break it up into two cases where either. Yep. Okay. Yeah, from every side here. And I get x equals 2 and x equals -6. So notice that those solutions do match the ones on the graph. All right, so let's go quicker. 28. What is the value of b for 28? Yeah, +4. It's the opposite. What's the value of c? C is equal to the 2 there. I think it looks like d, yeah. All right, so d is the solution to 28. D is the graph. And then notice here I could also line that up. And what was the value of c? 2. And yeah, so notice this is what my solutions would be, just those green dots, which are 2 and 6. And that's also the solutions I would get if I solved it algebraically. Yeah? Yeah. All right, let's see. 29, what's the value of Bravo? 2, what's the value of Charlie? All right, and let's see. So midpoint of 2, distances of 4, looks like C. And then process of elimination, I'm guessing A. Bravo here would have been -4. And Charlie would have been 2, yeah. Yeah, the equation was always x minus b, my midpoint. And so, yeah, so it's always going to be the opposite of that number. That oppositeness is going to show up in a lot of different types of equations and formulas as we go through this course. But of course. Let's see, here's a problem you guys didn't have last night, but future generations of Waddy Mathers are going to do this problem. So let's see if, could you do this without a graph? So if I've got x equals -6 and x equals 10 are my solutions, How could I find the value of b? It's not on your notes. Add them together and divide by 2, right? Because b is going to be the midpoint. So that's going to be 4 divided by 2. I get b equals 2. How could I find the value of c? I could see how far they are away from each other, and c would be half of that distance. Or I could see how far one of them is from the midpoint. All right, do you guys see how that's going to be the same thing? Right, so if I take one of those solutions and subtract the midpoint, that's going to give me c. Or I could have done 10 minus negative 6 and divide by 2. 10 minus negative 6 is 16 divided by 2. Notice also 8. So when I'm writing my equation, x, absolute value of x minus Bravo equals Charlie, what's going to go here? Yeah, 2. So notice this is a positive 2, but in my equation it would be a negative 2 and equals 8. And the Charlie is always going to be positive because it's a distance, okay? And we also would know that if I asked you to solve an equation where it was equal to a negative, you would say, no, Mr. Waddy, you can't make me solve that. That problem has no solution, right? And you would be correct. Let's verify this. Yeah, you'd probably be more polite about it. So let's see. So if b is 2, right? So x minus 2, and the distances are 8. Oh, guess what? Watch this. I'm going to change my slider. Let me go as far as 8. How about that? La policía. All right, so it looks like this would be my graph, something like this. And are my solutions, yeah, 10 and negative 6. Negative 6 and 10. Yeah, there's my solutions. So that does, in fact, work out. All right, so it's kind of weird. We're solving these like forwards and backwards, and yeah, that's a classic algebra thing to do, by the way. All right, this problem was a little bit meh because they use different letters than me. What would I have called these? That would have been my C. Yeah. This is my B. Yep. And these would have been my X's. I could call that X1 and X2 if I wanted. So if I'm plugging in these here, it's going to be x minus b, which fortunately my b agrees with their b in the absolute values, and equals Charlie. But what's their Charlie? Dave. Delta. Or Dave. Okay. All right. Yeah. I could see that. So that's the general form that they had. I had a slightly different general form, but you can kind of see the idea of how it works. Yeah, write a pass, and I'll sign it. Write a pass. There's lots of videos with me sneezing. Actually, a rare treat-ish would be a video of me blowing my nose. I used to be super self-conscious of going, like blowing nose sounds. In fact, when I started dating my wife, when I had to blow my nose, like if we like pulled up to a store, I'd be like, can you get out of the car so I can blow my nose with a tissue? Like, I don't want to do it around you. I felt weird. But now there's videos on the internet of me doing said thing, and there you go. So let's see, question 41. What do you guys think about solving this? How do I solve it? Yeah, the absolute value is already by itself. There we go. So break it up. So either 3h plus 1 is 7h, or 3h plus 1 is equal to negative 7h. I forgot that you couldn't write. My bad. Crazy Mr. Waddy. There you go. So now I could solve each of these separately. Over here, I'm going to bring the 3h over here. So I'll get 1 equals 4h. And now what would I do to get h? Yeah, guys, are you feeling it? I've trained you. You guys have become a pack of algebra ninjas. This is amazing. Is the other side the same? This one was positive. This one's negative. Tell you what, over here, let's say I added 7h to both sides. Not the only way you could have done this. This one will take one more step. What happens when I have nothing? What's the mathematical number for nothing? 0. Sometimes people just like stop writing things and they'll actually just like then just be confused. But it's equal to 0. 0 exists. Yeah, subtract 1. Oh, guys, we're getting there. 10h equals, notice, trying to line up my equal signs as best as I can. And then divide both sides by, no, not h, 10. And so I got h equals negative 1/10. So I think we did everything right here, except, wait a minute, they said check your solution. Yeah, let's find out what happens here. If I plug a quarter, oh my goodness, this is awful. Oh my goodness. If I plug a fourth into these, I apologize for the fraction work. 3 times a fourth plus 1, is that going to equal 7 times a fourth? All right. So that's going to be abs-val of 3/4 plus 1. I could rewrite 1 as 4/4. Do you guys agree with that? Yeah? Equals 7 times a quarter is the same as 7/4. So 3/4 plus 4/4 is 7/4. And the abs-val of 7/4 is equal to 7/4. So this seems to work out, right? Ching, that's true. So I think this is a real solution right there. Let's check the t'other one. Yeah, so I'll plug in negative 1/10. So 3 times negative 1/10, there we go, plus 1 equals 7 times negative 1/10. Let's see if this one verifies. So this is going to be negative 3/10 plus, how could I convert 1 to tenths? 10/10? I think so. 10/10 equals negative 7/10. And actually, you might already get suspicious right now. 7 times negative 1/10. All right. All right. It's all right. Sometimes I make mistakes, so I need you guys to, always be checking my work. Negative 3/10 plus 7/10 is 7/10. And is, so this solution is extraneous. And even though we did, there we go. Even though we did everything right, that solution still didn't work for the original problem. So this absolute value equation only had one solution, and beware, sometimes both solutions are extraneous, and the absolute value problem is just super picky and too good for us. It's just like, you're never going to be happy, absolute value problem. I don't know who you think you are, but we did all of our algebra right, and it's still not good enough for you? Yeah, nice try, friend. Well, anyways, have a good day, friendly friends. Adios.